Hey class, welcome back. On the board behind me we see some of the wrap-up stuff from week 23, which happens to be the last week of the second trimester. For the third trimester we're going to be going into the 11 body systems. That will be our key terms, so a little housekeeping here. Those will be our key terms in the first week of the third trimester. Originally they were assigned a little bit earlier, but we had a guest lecture this week. It was kind of a busy week, and also we're wrapping up the trimester. So we're going to jump in starting at week 24 with those 11 body systems that you guys defined probably already. I received a couple of them via email, so thanks. All right, on CNN a couple days ago, they were talking about two different things. That's what we start off with today, CNN 10. The first was Texas and everything from freezing down there to pipes bursting and how that relates to what Dr. Guccione was talking about. My sister, I've got a brother and a sister, as you know. My brother's back in New Hampshire trying to figure out how to golf in the winter. My sister, for some reason, moved from here, sunny California, to Texas, where they've got mosquitoes and giant cockroaches. And what they recently had, of course, was a freeze going on down there. Now, if you remember Dr. Guccione talking a little bit about the water molecule, remember it's got a polar side, and one of the characteristics she talked about with water was that as it freezes, as it loses kinetic energy, and the molecules aren't moving around as much as they are in the liquid state, they tend to line up. In other words, if you think about the plus and the minus side, they tend to stick together. It's a little bit like if we were in class talking about this, and if this was a normal school year, we would have students kind of hold hands with our arms out straight. And you notice you're not quite as flexible in that position as you are if you're just kind of like a mosh pit and everyone's kind of dancing around. And that is one of the reasons that water becomes less dense as it freezes. The molecules literally line up. This is a huge, important characteristic of water, because if it wasn't for this characteristic, ice wouldn't float. And lakes, rivers there would be probably no rivers actually. Lakes and oceans would freeze from the bottom up, making it very, very difficult to have any life. Also, speaking of life, their next story up there was about the Mars Rover. Now, the Mars Rover is looking for life in what we think is like a dry lake bed on Mars. If you look where the life on Mars might have been, it's in this place where there's no more liquid water, but there might be salty water, perhaps under the surface, or there might have been salty water there at one time. Also, you may or may not know that salt lowers the freezing point of water. This makes sense if you think about this in terms of chemistry. The salt, the Na, the Cl, the sodium, and the chlorine get sort of in between the water molecules. Salty water can still freeze. It just freezes at a much lower temperature than fresh water. This is why when you go someplace like the Sierra Nevada in the wintertime, they pour a combination of salt and sand on the road. The sand helps with traction on cars, friction, and the salt helps kind of get in the way of the water molecules from combining and freezing. And that helps a little bit, keeping it in the liquid state so cars can drive more safely. Okay, if you're looking at a couple of the things that they talked about, the pipes freezing in Texas. My sister recently had the problem of a pipe bursting in her house, and they couldn't get any fresh water through the pipes because I saw this really cool demonstration from a San Francisco State professor who took a sealed metal container. He filled it all the way to the top with water. He sealed it up. It was made just for this demonstration purpose. It was like a cylinder with a screw on top. He put it just in a regular refrigerator that got down below 32 degrees Fahrenheit, below 0 Celsius, freezing point of water. And he let it sit in there, and it, boom, blew apart this metal container, no problem. When you put water in like a copper pipe, that's how we usually get our water to our house. When that water freezes, there's not much that's going to stop it. Also, this does relate a little bit to something that we saw a while ago when we were doing the rock cycle. You might remember Alex Honnold, the guy who was climbing up El Capitan, free climbing, free solo. We just saw that one part to show granite and igneous rock. When you go to a place like the Sierra, you go to a place like Yosemite, they have rock falls all the time. One of the reasons that you have a rock fall, you get water in the cracks of the rock that rains or snow melts, and you get water in the cracks. But then at night, it might freeze. As it freezes, guess what? It expands a little bit. It will push that rock right apart. That's one of the reasons that you have rock falls and things like that in Yosemite, in the Sierra, around Tahoe, because the water gets in the cracks of the rock. Not much is going to stop it. You kind of see something similar going on here at Montera Mountain when you check out some of the granite that breaks apart here, not from freezing, Here near the ocean, we have salt crystals that grow within the granite over there at Montera Mountain. Really, basically peel apart the granite. It's kind of a cool process to watch. I'll try and get some film of that next time I head on out there. All right, key terms. So week 24, quick reminder again. Our key terms starting off our third trimester will be the 11 body systems. We are talking about the skeletal system right now. One of the things with the 11 body systems is this. With our distance learning, we're trying to kind of incorporate what we would normally be doing with evolution with some of our body systems, which is awesomely great to do because hopefully it's showing the students, it's giving us an opportunity to show the crossovers in science. With the skeletal system, we're going to talk about two main things. One, if you look at its connection with the immune system. If you look at this little piece of vertebrae I picked up right here at a beach nearby, just happened to come across it. I got to be honest, I'm not quite sure what animal this is. In the comments, maybe I'll turn on the comments for this video. Make your guesses on it based on its size, but look at the sponginess on the inside there. That's important. It's not just spongy because it was falling apart after it had been exposed to weather at the ocean. It is naturally like that on the inside of a bone. The inside of a bone, I'm going to put my glasses over my cord there. The inside of a bone, the bone marrow has a close connection with the immune system because that is where red blood cells are made. That is where a number of different types of white blood cells are made. And you might remember white blood cells, critically important to fighting off viruses. And in the immune system, the white blood cells are sort of patrolling the blood all the time for invaders. And they're also actively looking for things they've seen before. This is when we talked a little bit about vaccines. Also platelets. Platelets aren't exactly cells. They're kind of like pieces of cells that get together and cause scabbing up. If you fall and you get like a skinned elbow or something like that, you see a scab on that part right there. Platelets are another part of the immune system. They patch up the wounds and they keep things from getting on in. So that's a very, very important part of what we're talking about with the immune system and what we're talking about with the skeletal system when we're talking about the 11 body systems, how it relates to immunity. Moving on from the immunity part of it and the spongy tissue on the inside that makes the cells, we also are checking out the skeletal system. Switch out the boards here. We're also checking out the skeletal system because of this, that bone that I just showed you a second ago right here. This is a vertebrae. Vertebrae, you've got, if you're human and you're watching this, you've got 33 of these all the way down your back. It protects your spinal cord. A spinal injury, in other words, the nerves that come from your brain down the spinal cord to the rest of your body, it has to travel through a cord that goes through the vertebrae. This is why it's critically important to protect your spinal cord. A couple things about this. A student from a previous class mentioned that her uncle was dealing with spinal injuries after an accident down the peninsula. You may or may not have heard about a person who's been in a serious accident. If you're over here at Oceana Pool, you see they've got a board that you lay on if anyone is suspected of having like an injury from jumping into a pool or something like that. It's because it's critically important not to move somebody if they end up having a spinal injury, because you don't want to damage the nerve cord that goes up through the center of these. Very, very important to keep them nice and immobile. Sometimes people think after a car accident, let's pull this person over to the side or something like that. Never do that. It's a good thing to keep them very, very still until medical personnel on the site can stabilize the spinal cord or stabilize the vertebrae and make sure the spinal cord doesn't get injured any further. All right, moving on from the bones, they're made of collagen and a framework of proteins. Now this is where it ties in with evolution. It's critically important because when you look at bones like this, they are one of the big pieces of evidence that we have for evolution. Normally we would be doing this whole unit right now on Darwin and evolution. We're touching on it as we go through the body systems. It's a cool way to do it because we are lucky that the bones are one of the things that tend to survive after the rest of a body decays. So if you look at an animal that dies in the wild, the soft parts usually fall apart very, very quickly. But if conditions are just right, the bones can last. Now, a quick word about fossils. Remember, we find fossils, get my pointer here, in the sedimentary rock, the rock with the layers. I believe I showed a picture of local sedimentary rock right over here near Devil's Slide a little while ago. The sedimentary rock is great for having remains of once living things. When you're looking at fossils, though, most of the time when you're looking at a bone, now this is an actual piece of a bone, just found at Linamar Beach over there, but when you're looking at a bone, most of the time, like say in a museum, you walk into California Academy of Sciences, you see that big T-Rex as you walk on in. Those are not the actual bones of the T-Rex that lived more than 70 million years ago. What you're really looking at are rocks in the shape of a bone. What usually happens is a bone like this, if conditions are just right, it gets buried in such a way that minerals, basically little rocks, will replace the organic parts of the bone, and you're looking essentially at a rock that is in the shape of the bone that was once there. There are places where you can find the actual bones, certainly around the beach or around here. If you've ever been to Los Angeles and you've checked out the La Brea tar pits, that's a very cool place to go. They've got a museum there where there are, exactly what it sounds like, large pools of a very crude oil, and when animals would fall into this oil, they would get essentially fossilized, but what would happen is obviously they would die in the thick tarry oil, but when they pull them out and they clean off these bones, you're looking in those cases, like when you look at dire wolves and these giant sloths, you're looking at the actual bones. That's one of the rare cases, because this was only a few thousand years ago that these things got stuck. However, in the case of dinosaurs, you're looking at things tens of millions of years ago. So the bones are long gone. Okay, the other thing about using skeletons to check out evolution, and this is exceptionally cool, is as you trace these things through time, you can see the different shapes from the bones from species to species. Let's take a human arm as an example. Human arm right here, you've got the humerus, the bone up here, the radius, the ulna. Simplifying this similar picture, by the way, or one similar to it is in your book. In the phalanges, basically your fingers. And if you're looking at something like this with a human, when you look at a bird, humans and birds obviously don't use their limbs exactly the same way, but birds have the same structure, bone for bone, that we do. Now, obviously the bones are in a different shape. If you look at their radius, it's much larger. It's obviously the wings of the bird. If you look, for example, at a bat, obviously bats fly as well as birds do, or also fly like birds do, but the thing is, they use a different strategy. Evolution has introduced a slightly different strategy for the way bats fly. Instead of having a large radius, that is their wing, instead, bats have very, very long phalanges, and essentially they kind of fly like this. They're fluttering their fingers, if you will. They're not really fingers anymore. They're like a flesh-colored, webby appendage. You see bats fluttering around like that. Big fan of bats, killing those mosquitoes when they're cruising around in the summertime. If you look at bats and birds, bone for bone, again, the very same bones in terms of the same bones in the same places, very different shapes. We call this homologous structures, similar structures that have evolved over the years for different reasons in terms of what function they're serving. Look, for example, at the last badly drawn picture over here, but it's also in your textbook, a porpoise. Last I checked, porpoises can't play baseball very well because they don't have the phalanges so they can grasp and throw a baseball, but they're excellent, excellent swimmers. Why? If you look again, bone for bone in their fins, they've got the exact same bones that we do, that a bird does, that a bat does. It's just they're simply in a slightly different shape. When you're looking at a very large whale skeleton, for example, right up here in Marin County, you may or may not have seen it for yourself. They have this in a couple places in the Bay Area. At the Marin Discovery Museum and a couple other places, they've got all the bones of a whale laid out, and you can actually see the remains of what are leg bones in a whale. You think, leg bones in a whale? Whales don't have legs. Last time I was surfing over at Linamar Beach, taking a break to have a taco on the beach there from the Taco Bell. I did not see any whales walk up on the beach and try and grab a chalupa. No, but they do have leg bones that are within their body. In other words, they've evolved so they don't obviously use those anymore. Their bodies are streamlined for swimming now, but you can tell, and it's more evidence for evolution, that they were once land animals. And as a matter of fact, they were closely related to something that kind of looked like a wolf somewhere in the neighborhood of 40 million years ago that lived near the water, that eventually adapted through natural selection to live in the sea, live in the ocean. And when you're looking at the structures that are left behind by those bones right there, you're looking at not only a part of the immune system, but you're looking at one of the main pieces of evidence for evolution, one of the main pieces of evidence for evolution that Darwin brought back from his voyage, his 5-year voyage along the HMS Beagle. Look for the notes online. Quick reminder, we've got our Friday quiz, our Friday test, which is due by the end of the day on tomorrow. And our week 24 key terms will be the first grade of the third trimester. Looking forward to seeing you all back here in person, everybody. Hope that gives you a quick rundown of where we've been. I'll post these notes, of course. I'll write them out and post them. Have a wonderful week 23, and I'll see you later. Bye-bye. Oh, I missed the off button.